Hey, we're doing fractions in algebra land. What do you reckon we want to do next? Here's a question for you. And if you looked at the earlier presentation, you know that we've looked at addition and subtraction, so have a look up here. Oh yeah, of course, multiplication and division. Okay, do you remember anything about multiplication of fractions before we go to algebra? Look at this creature here, and this one over here. Well, it's going to look pretty hard to me. I reckon we should go back and revise how to do multiplication, and down here, division of ordinary fractions before we go into algebra land and do them there. So let's revise though. Come on down, let's have a look and see if you remember any of this stuff. Here's multiplication, purple, nice colour, eh? Anyway, so let's have a look. 2/3 by 5 over 4. What do? Do you remember? We multiply the numerators together. 2 by 5 is 10. Multiply the denominators together. 3 by 4 is 12. Okay, remember that stuff. 2/3 of 5 over 4, or 5/4 is done that way, and we could cancel, couldn't we? We're going to do this in a later presentation. Have a look at what cancelling really means, dividing top and bottom by 2 here, for example. Okay, what about this one over here? Does the same thing work there? 3 by 7 is 21, over 4 by 8 is 32, and can you cancel by anything there? 21 over 32. Might think about that. I don't think you can cancel by anything there. Anyway, keep thinking. You might come up with something. Let's have a look at how that works in Xland, in algebra. Okay, just remembering, we've introduced a pro-numeral here to replace a missing number. So it is just standing for a number. So we should be able to do with the x's exactly what we did with the ordinary numbers. So let's try it. So here, x by x is x squared, and dividing by 3 by 4 is 12. Is that okay? It's the same rule, isn't it? And shouldn't it be? Because don't pick on x, it only stands for a missing number. What about this one over here? X by 2x. Well, we've done this before. X by x is x squared. So it's 2x squared over 4 by 4 is 16. Could you think you could simplify this at all? Anything that will divide into top and bottom line? Have a look. What do you think? What about this? 2 and 2 goes once. 2 and 16 goes 8. So you could simplify that down to x squared over 8. Are you getting the hang of it? You don't want to be frightened of algebraic expressions. Don't pick on x. He's a number, and we just want to work with it in the usual way. So come down and what have we been doing here? Let's summarise it, and you can put this in your notes here. To multiply 2 or more fractions, we multiply the numerators. Now hang on, what's that? Numerator's a big name, mate. That's the top line of your fraction. To form the new numerator and multiply the denominators. Denominators is the bottom line, isn't it, of your fraction. So just remembering that. This is all supposed to be stuff you saw before, but if you didn't, time to catch up now. So let's summarise what we've done. Fraction a over b times c over d, multiply the tops together, get AC. Remember, we leave out the timesing sign. And b times d, there it is there. But in algebra notation, we leave that timesing out. So it's AC over BD. Is that fair enough? What do you think? Let's come down and practice some. And these screen clippings are from Hayes and Harris Publications, the Year 9 National Curriculum textbook here. So let's try some in algebra land. Here's one here. So a times b, there it is, over b times 2, there it is. And see what they've done? They've done the cancelling right there, and you end up with a over 2. You might like to do that slightly differently. A by b, and then b by 2. The convention is you put the number in front, isn't it? A times b over 2 times b, and maybe cancel then. B's into the top line, the bottom line, and come in that way. I'll leave that up to you. That's your choice. Think about it in both ways there. Oh, n over 3 times 6. Oh, 6 is a problem. Do you remember that from the last presentation? When you've got an integer or a whole number and a fraction, we change the integer to a fraction 6 over 1. Do you remember that? Okay, 6 over 1. So now it's n times 6, and I really would prefer you to put 6n there at that stage. And in the bottom, 3 times 1 is 3. Now we look for any common factors, something that will divide into top and bottom. So 3 into 3 goes once and 6 goes twice. So it's 2n over 1, or just 2n. Look at this little dude here, suggesting always look for common factors to cancel, so that you come up with the simplest expression at the end. Okay, let's come down and have a go. Here are some little questions for you, and what I want you to do is just go through slowly and carefully, and as you do one or two, toggle the video forward and look at the answers. They're down below. Don't want you to keep repeating the same error, so you need to go backwards and forwards and just check it out as you go. Please remember, in this problem, an integer 8 can be thought of as 8 over 1, so that it matches up with the other fractions in the problem. Okay, let's have a look. I'll give you a chance now to pause the presentation and have a go. I'll go on and show you the answers now. Okay, so here they are. Check your work out and see how you're going. If you get something wrong, you've got to go back and have a look. Maybe look at what I did in the example and have another go. All right, let's go on. What are we going to do next? I reckon we need to do a bit of division. Okay. Now, division's sometimes a bit of a mystery to students in fraction land. Here we've got 2/3 divided by 5 over 4. And do you remember the rule? And that is division of fractions, you multiply by the reciprocal, or the bottom one turned upside down. Wow, I wonder where that came from. I think we should look at that and just check that out. But this is the problem, isn't it? Where you have one fraction over another, and there's the rule. You multiply, division changes to multiplication, and you turn the second one or the bottom one upside down. Wow. I don't know. Did you ever understand that rule? I think we should go through that. Anyway, let's do it here now. 2 by 4 is 8, and 3 times 5 is 15. So we've actually changed division into a multiplication problem. Okay, under that rule. What about this one over here? 3/4 divided by 7/8. You could write it like this. Okay, and then the rule says 3/4 times 8 over 7. What do you spot there? Do you want to just multiply the tops and the bottoms as before? Or do you spot something here? Hey, look at that. 4s into 4 goes, once 4s into 8 goes 2. Then we could do the timesing as 6 over 7. Do you get it? Okay, and that's what we're doing. Well, let's do it for some algebraic fractions as well. We've created quite a big thing here in algebra land, haven't we? Now we've got pronumerals. We've got to be able to do everything that we do with numbers in pronumeral land. Okay, bit of a challenge. Here we go. X over 3 divided by x over 4. And what's the rule say? Don't pick on x, there's only a little mystery number there. But we're going to multiply by the fraction turned upside down, or the reciprocal of that fraction. Hey, this is a good one. What do you notice? Common factor of x. X in itself goes once, and here, remember, x is the same number in all parts of the problem. Okay, so that's common and you can cancel it. So we're left with 4 over 3. What about this one over here? We might think of this as x over 4 divided by 2x over 4. Okay, let's use the rule again. I hate this rule business because you don't even know why it works, do you? Oh well, I'm going to show you in a minute. So we're timesing by the fraction turned upside down. Oh, common factor there. 4's into 4 was once there, and x in itself goes once, into 2x goes twice. Wow, that came down to be a simple answer. The top line is 1 by 1 is 1 over 1 by 2 is 2. It's a half. Whoever thought that that dude there came to a half? Maths is magic, mate. Absolutely magic. Okay, so what we're going to do, I'm going to get you to do some problems in a minute. Come down here and let's look at the rule from Hayes and Harris there. So we'll just go back up here. And there's the rule. To divide by a fraction, we multiply by its reciprocal. Wow, reciprocal. Turned upside down. He says by swapping. Oh, that's not very good language mathematically, mate. No. Reciprocal means multiplying by the fraction inverted or turned upside down, if you like. And this is what we've been doing. But you're a budding young mathematician. Surely you're going to ask, why? How can you change multiplication into, or division into multiplication? That just doesn't seem to make sense. Let's see if we can look at where the rule came from. We should have been asking this back in about year 7. So 3/4 divided by 2/3. How can you split 3/4 into a 2/3 batch, if you like? Well, the usual definition of division doesn't really hold for fractions very well, but let's see if we can work out a way of doing this problem. So let's multiply both top and bottom here of this problem by 3/2. Now, in an earlier presentation we said that this is okay, isn't it? This doesn't change the meaning of the fraction because this is effectively 1. Multiplying by 3/2 over 3/2 cancels to 1. So we should be able to do that. But something really magic happens here, mate. 3/4 by 3/2 in the top line. And look at what happens in the bottom line. When we multiply these two together, it becomes 2/3 by 3/2. Wow, look at that. Now you know why I multiply by 3/2. What's the problem look like now? Here it comes. Watch it. This came to 1, didn't it? Cancel itself out there, the whole thing. So the final answer to our division problem was this little dude. The bottom line disappeared. That's math magic, mate. So here you can see, what's a quick way of explaining to people how to do that problem? It's to say, here it is, the top line, change the division to timesing by the reciprocal of the bottom line, or the bottom line turned upside down. And here's the reason why the rule works. Because in doing that, you're effectively doing this step, and the bottom line cancels itself out there to 1. Okay, so you might think about that. Let's do another one. Now let's do this one down here. A over B divided by C over D. Now you might say, well, how can I do that division? Well, let's change it by multiplying the top line by the reciprocal, D over C, and the bottom line by D over C. Okay, so the top line becomes A over B times D over C, and the bottom line, we times these together, it all cancels out to 1. Hey, we've just shown it in general now. So this division, A over B divided by C over D, rather than going through these steps, we could pop straight across to the answer and say it's the same as timesing by the bottom fraction turned upside down, or the reciprocal of the bottom fraction. See, because we get rid of the fraction in the bottom line, so it's not a problem for us to think about anymore. Interesting stuff, isn't it? I just want to advertise something right here on this page now. It's Huddy's hierarchy. There's a rule, which you probably learnt off, and then there's the concept, and I hope through this little discussion now, you got up to the top of the hierarchy. I see it. Hey, I actually get why that flicks over and we change division into multiplication. Don't stay at the bottom, mate. Don't just learn off rules and always have little questions in your mind on how it works, because later on you're going to need to know how all the bits and pieces work. All right, are you ready? I think I've got to get you to do something. I'm getting tired of doing all this. I think you should do some work now. Okay, so here we go. Let's have a look at this problem here. One last example, and then I'll let you loose on all these problems. So we've got a division problem here, and we could write this, remember, as 2 over A divided by A over B. Okay, or like this. So what are we going to do? The division now is equivalent to the multiplication by the fraction turned upside down, or the reciprocal. So we've got this doofy, and now it's 2 by B, which is 2B, and A by A, which is A squared. Remember, a term times itself in algebra land, or all through mathematics, is the square, A squared. Okay, oh, look at this. Look at what they've done to us again. 4. I don't like 4. I don't like 4. Not in fraction land. 4 has got to be written as 4 over 1. So now it's 4 over 1 divided by 2 over x. And I'd like to go into that little intermediate step there. And if I'm dividing by a fraction, I'm going to multiply by fraction turned upside down, the reciprocal. And so now 4 times x over 1 times 2. Better said, I'd rather you wrote this, 4x over 2. Your algebra rules, leave out the timesing sign, not like the book's done there. So now we can cancel 2 and 2 goes once, into 4 goes 2. Got 2x over 1, which we can just write as 2x. Now you know everything. So it's your turn. So here we go. A few little problems there for you. Just watch out for expressions here which are not fractions. You'll need to call them, like in that case, b over 1, and so on. So in fraction land, it pays you to write integers as a fraction by having the bottom line over 1 there, or the top line over the bottom line of 1. Alright, so this is getting a bit challenging. So I want you to do a couple, pause it, and look ahead at the answers, then go back so you check you're getting a few right there. Don't practice doing the wrong thing. Okay, so I'm going to toggle forward here now and show you the answers. So there they are. So you need to mark your work and check the ones you couldn't get. Check your work with your teacher and get some help there. Okay, so that's the end of this presentation. There's one more in the fraction work to go. So I'll catch you then. Cheers for now.